Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Okay, so I've decided to make a short video dedicated to bias power supply for a fixed bias amp and what I feel is the right way to design them. This is the KT120 monoblock I'm using for an example, but this could be any amplifier, push-pull, doesn't matter. So what we're doing here is we're creating a negative voltage to apply to the grid of a tube to bias it, instead of using the voltage drop across a cathode resistor to bias the tube. And the benefits of that are you can usually get more power, especially out of a push-pull amp. On a single-ended amp, especially if you have a high current output tube, you don't have to deal with the heat generated by a giant cathode resistor. And it also allows you to use the full voltage of the power supply across the tube. So let's go over how and why of designing a good bias supply. Here we are pulling 50 volts AC off of the primary winding, off a secondary tab. And comes over here, we have a diode. This is going to be a half-wave rectifier, which is pointing what normally would be considered backwards. But it's not in this case because we are trying to create negative voltage. So only the lower half of the AC wave comes through the diode. Now, in a single-ended amp, you probably want to use something like this 100 UF cap. In a push-pull amp, because they're better at canceling the noise that could be generated, you can probably get away with a 10 UF here, but it's not going to hurt anything to put a larger one. Here's the critical thing to understand is when you're working with a negative power supply or a negative voltage supply like this is, the ground is positive in relation to the voltage in the circuit. So if you use polarized capacitors, you have to put the positive towards the ground, which is obviously backwards from what we're used to doing. But again, we have negative voltage here, and so the ground is positive in relation to that. So voltage comes along here, gets smoothed out by this cap. Then we have this potentiometer, and in my opinion, you want to keep this value around 10K on this potentiometer. You don't want a lot of resistance in this circuit because this is the pathway for the grid leak voltage to get to ground. So we have a 10K pot here. The purpose of this resistor, which will vary depending on the amplifier, is to limit how low the voltage can be on the bias adjustment. And by low, I mean closer to zero. So in this case, I don't want to go below negative 30 volts or closer to zero than that, given we're going to have somewhere around 65 to 70 volts along this rail here, the top part. If we set this at the same value of this pot, that means if this is turned all the way down, we'll have a voltage divider of 10K and 10K, and that will end up with around negative 32 volts or so. That is the minimum that it can be set, and that helps protect from setting the negative voltage too close to zero, which would make the tube red plate and melt stuff inside the amp and just overall be a very bad thing. Even negative 32 volts could end up making the tube red plate, but it's not going to just instantly destroy stuff. So that's the purpose of this resistor, and you'll want to calculate the size of this based on how much voltage you think you're going to have here after this diode, and what the lowest negative voltage, or the closest to zero, that you want this pot to be able to be adjusted to protect yourself or any other end user from setting the bias too low and destroying the amplifier. So then normally the pathway will go down here, go through this pot, and then the negative voltage will come out here and go to the grid leak resistor. And then you need to look at the tube data sheet to see what the maximum value of the grid leak resistor can be with a fixed bias, and don't exceed that. And then that goes to the grid of the tube, provides the negative bias, which sets the operating point of the tube. And we have this final cap on the output to just help smooth out the ripple of this voltage that's going to the grid of the tube, because it would clearly be audible as far as hum if you have a AC ripple in this lead going to the grid of the tube. So the last piece here is this 100K resistor here. And I've had people ask, like, what is the purpose of this? Well, in normal operation, it does very little. And you want it to be about 10 times the size of this potentiometer as far as resistance, so that it doesn't have much impact on this adjustment. The reason it's here is in case this potentiometer fails, and by that I mean this wiper becomes disconnected from this for some reason, or this burns up or gets corroded, or anything like that happens where this doesn't have the connection to this negative supply, this is a backup, so that no matter what happens, we will always have negative voltage going out of our bias supply to the grid of the tube. And what would happen in practice is if this goes open, then the full voltage up here will then go through this 100K resistor to the tube and basically just turn the tube off to keep bad things from happening. Without this, if this goes open, the grid of the tube is going to go to zero or even positive, and the tube's going to instantly red plate and start blowing up stuff inside the amplifier. So, you could end up with destroyed output transformers. At best, hopefully you have a sense resistor or some sort of small resistor on the cathode of the tube. I usually use a 10 ohm resistor, about 1 watt or sometimes a half a watt depending on the amplifier, and that will act like a fuse and keep it from blowing up the amplifier. And let me find you an example of that. So you can see in this amplifier we have a 10 ohm resistor between the cathode and the ground. Then we have test points here. We can measure the millivolts between these 2 points, and that'll tell us how much current is going through the tube. And it also provides a safety valve. If you set this at a half a watt or a 1 watt resistor, again depending on the size of the tube and the current running through it, if the tube does short out or it red plates and massive current starts blasting through the tube, this resistor will pop before it starts melting the windings of the output transformer and destroying stuff. So hopefully this helps you understand better the purpose of the bias supply, how it works, and having some safety backup things to your amplifier design to keep them from destroying themselves in case something wrong happens and the potentiometer quits working, which has been known to happen. So hope you enjoyed this video. If you did, please subscribe to the channel. Please like the video, and we'll see you soon. Have a nice day.